for autonomous characters in interactive fiction. I'm Chris Martens, an assistant professor at North Carolina State University, and I worked on this paper with my master's student, Owais Iqbal, who's now an alumnus of my lab. My lab is called Poem, Principles of Expressive Machines. All of our projects, or most of our projects, are named after types of poems, hence Villanelle. So when I'm talking about autonomous characters, I'm really taking inspiration from a lot of existing narrative works that I think do this kind of thing really well by creating a space of play in which characters are not just sort of props for the player to interact with, but really kind of are bringing life to the world by moving around without response to the characters. So games like, of course, the seminal Facade, the Merchant of Venice game that uses planning to control character goals, Blood and Laurels, which uses the Versu engine that Emily Short had a big hand in, and most recently, I'm a big fan of the Elsinore game produced by Golden Globes, just came out this year. So what a lot of these have in common is that there's many simultaneous actors, many simultaneous characters interacting both in places where the player can observe them and otherwise. These characters are responsive to interruptions, so the player can have some impact on the course of what the characters are doing, but most importantly, they continue their behaviors even when the player isn't interacting with them. So this is kind of the key piece of the definition that I'm looking for autonomous characters. And as we all know, when working on interactive narrative experiences, particularly ones with what you might think of as sort of complex programming that you have to do to make them work right, there's skills that have to work together. Narrative design and programming, as we heard in our keynote this morning, really are best when they're kind of an iterative process where each is building on the other. So we really need better authoring support for autonomous characters that people who are also very good at narrative design find approachable and learnable. So that leads me to the research question of what exactly is an approachable and learnable kind of way to author these autonomous characters, and specifically what's a good computational model. So I have some examples of what I consider to be kind of benchmark-like usable authoring tools, things like Twine and RedPie, and even in Form 7, just in the sense that they're widely used and adopted by the interactive narrative authoring community. Villanelle's approach takes some inspiration from an authoring tool and system commonly used in AAA games, usually kind of real-time 3D games, called behavior trees. So the hypothesis is that we might be able to reuse this formalism, this tool for designing behaviors in another setting as a way in interactive fiction. So I'm going to continue the rest of the talk telling you Villanelle's model of behavior trees. It's pretty standard, but I'll go over them in case you don't have familiarity with that. I'll talk about the authoring tool we designed, discuss some example games and sort of evidence of what we can do with it so far, and then conclude. So Villanelle's behavior trees, as I said, are inspired by tools that I think have been around since at least the early 2000s for controlling usually enemy behavior in simulators, sort of point-and-shoot and strategy games. And they often are integrated into most of the existing hobbyist game development tools for building such games, including Unity and Unreal Engine. This is an example where you can see someone's behavior tree kind of running alongside the simulation of an AI character. So as a programming model, well, at the simplest level, you can think of them as, well, they're about scripting autonomous characters. And when we're scripting a character, at the first level, we just want to give them a set of things on their to-do list they're going to accomplish. And so in behavior trees, these are called sequences. So you might have a sequence of actions for your NPC where they take a key, they unlock the door, they open the door, they go through. On the other hand, because these behaviors are meant to run in environments that are uncertain and changing, and where the player's actions and other NPC actions can have some impact on what's going on in the environment, well, the sequences may not always work as written, right? You may have some uncertainty that you need to test for in the environment. So the formal model of a sequence in a behavior tree is that it succeeds, so every behavior tree either succeeds or fails, and a sequence succeeds if all of its children succeed, and it fails the first time one of those children fails. So if we want to introduce this condition in the environment, we might say, well, okay, if I already have the key, then I can go ahead and do the sequence of unlocking, opening, going through the door, and a condition. So a condition is another type of behavior tree node, which immediately succeeds or fails based on whether the condition is true in the current environment. Now, if we wanted to introduce another sequence of actions for what to do when we don't have the key, and then we provide a sequence, we can provide another sequence for that. We might look for the key first and then take it. And we can combine these nodes using what's called a selector, which is a node that succeeds the first time one of its children succeeds and fails only if all of them fail. Now, the only way that this sort of behavior tree makes sense as an overall description of behavior is if we're iterating it repeatedly. So on the first evaluate, we do a repeated evaluation of this tree. On the first run through, we might run our root node at the selector. We would see that the condition that we have the key fails, and so we move on from left to right in the children of the selector over to the next one. And so then the sequence runs, its children succeed, the whole sequence succeeds, and thus the whole tree succeeds. So that was iteration 1. And then on the next iteration, now something in our world state has changed. We've taken the key, so the condition will succeed, whereas previously it failed. And in this case, everything succeeds down the left branch of the tree, and that's how we satisfy the tree. So in summary, this is a sort of simple programming model where we have sequencing, branching, conditions, and repeated evaluation. And sort of the syntax tree of these programs is made explicit and visual and kind of manipulable in this way. So the one kind of innovation I would say that Villanelle brings into this is noticing that you can also use things that look a lot like behavior trees to structure user interactions, to structure the set of things that are available to the player of an interactive narrative. So we introduce new nodes for user interaction and user action, where we can give the, I don't have a laser pointer with me, so where we can give a text field and an effect, which itself can be a larger behavior tree. And then these will be rendered, in effect, these are kind of instructions for how to render the choices that are available to the player, along with a description of what they will do if the player selects that choice. And these can have conditions associated with them as well. So the runtime loop of Villanelle is, well, the three boxes in orange on my screen, just the ones at the top, I think, are the pieces that the author has to give to the engine. So this includes the initial state of the game, the user interaction tree, basically the options that are available to the user under different situations, and then the behavior trees.
Can you see it?
Yes, can you all see that? Yeah, okay. Yeah, so you have the user interaction tree, and all of the NPC behavior trees are also part of what's authored. Those are fed into the Villanelle engine and then rendered as a playable application. So this just kind of shows what happens when, like, as the player is interacting in the runtime loop. So the player makes some kind of choice. The zero step, I guess, is to first populate the playable application with the set of choices that are available in the initial state. The player makes a choice. That's processed by the user interaction tree to determine the effects of that choice, which can change the world state. And then all of the agent behavior trees are processed in turn, which then also have some effect on the world state, and this can then affect the available interactions that the player can make. So, okay, so now we're going to get into how we make this programming model available to our authors, and I'm going to walk you through the way the interface looks using an example my student Owais chose called Weird City Interloper, which is a parser-based interactive fiction game. It's kind of one of these parser-based games that could be sort of a choice-based game, but it has a lot of interactions with different characters and seemed to be a good fit for the tool. It's a very highly rated game on IMDb, released in 2014. So the Villanelle authoring tool is a standalone tool which has two tabs, a script tab and a play tab. And in the script tab, you're basically writing code. It's a variant of YAML, which is kind of just a universal syntax for building like slight modifications on lists of things with identifiers. And so, this is how the user interaction tree would be scripted in Villanelle, and this is what the play tab would normally look like. So the text of whatever whatever you write to display in the script gets put into kind of the upper passage, and then you have labeled choices available at the bottom of the screen. So I haven't showed you like the whole kind of zoomed out interface. So on one side you have this sort of text-based code editor, and on the other side we actually had a visual representation of the tree. We originally kind of wanted to make this more bidirectional, so you could directly edit the tree structure and switch to the code. Like if you wanted to, you could go back and forth. That's sort of in scope for future work, but right now it's you edit everything in text, and then it renders as the tree. So you can collapse and uncollapse nodes and see kind of how they're structured as a behavior tree. This is a behavior tree for one particular character. Every tree is associated with a character. The tool includes a continuous build environment, so every time you type something and save it, you're going to get new feedback, including syntax errors that will appear both at the bottom of the screen and in the tree to tell you specifically where in your code it is, and also compilation errors, which have to do with whether you sort of have made a well-formed behavior tree consisting of the appropriate fields. While you're playing, you also get a visualization of the tree, which we're thinking is going to be particularly useful for debugging, and has in our limited experience so far been pretty useful for debugging. And this is pretty standard again in a lot of PT offering tools for other game engines. But so we'll just show the tree as it's executing, and nodes that succeed are highlighted in green, nodes that fail are highlighted in red. So you can see there's a selector, this one on the left, and it's had 2 of its children fail, but then the third one succeeds. So just a handful of example games made with Villanelle. So I want to caveat this with, these are all, the 2 that I'm going to highlight are actually built with Villanelle's API, which is a TypeScript library. So we can also write code with Villanelle directly in TypeScript or JavaScript. Since TypeScript compiles to JavaScript, you can do either one. And we, so we currently, the tool itself, I don't think has really yet borne out evidence that it can be used in a full interactive experience, but we've used the API for this purpose, I think, pretty effectively. So for the API, there are functions you can call to construct the behavior trees, and then you add them to a global pool, and basically call world tick every time you want to update the world and show the next options to the user. So a couple of example games made with this API include, these were both games that were designed, really conceptualized as a team, but primarily of undergraduate students, many of whom didn't have computing backgrounds, and many of whom in fact had tried computer science and decided it wasn't for them, but were still really interested in games and narrative and storytelling, and were attracted to this project. So there's no hard evidence yet of usability by people without programming experience, but I think the anecdotal evidence so far is pretty strong. So this first one is called Space Escape, and it's basically a social survival premise where you're in a spaceship and something goes horribly wrong, and you're the captain, and you have to work together with your team and kind of listen to them and understand their skills so you can lead them effectively and solve the problem. So it's got themes of teamwork and listening, and all of these characters can have their own schedules of what they're going to do by default unless you intervene. And fundamentally, as a new game mechanic, we're actually saying the captain character can go up to one of these NPCs and attach a new behavior tree. The way of giving them orders is sort of by attaching a behavior tree to those characters. So my students, Tony Mosolf, Maddie Engling, Sasha Azad, and Owais were all contributors to this project. The second one is Ring Royale. This was showcased in the AID Playable Experiences this year. And this was a guildmaster simulator kind of concept, where again you're sort of, you might notice a theme, you're kind of a leader of a team, and you're kind of trying to not tell them directly what to do, but assign them to missions, and then whoever is not assigned to the missions can kind of roam around the guild and do things that serve their purposes. So whether that's training up stats or talking to other characters to increase their affinity with those characters, which might have impact on later missions. So this was developed with two wonderful undergraduates, Claire Christopher and Blue. All right, so the main takeaway kind of this whole project is that, well, it turns out turn-based behavior trees can be used for authoring character behaviors, along with player mediation. And that was honestly kind of a surprise to me, that we could incorporate the behavior trees as both how we author the autonomous characters and how we mediate the player interaction. So you can kind of use the same constructs to author both of those pieces to create interactive fiction. So that's kind of like the low-level takeaway for this project. I also couldn't help but including a more like kind of higher, like bigger picture takeaway, which is that to me, I think is really important when we're talking about authoring tools and challenges in authoring tools, not just to think about user experience, kind of quality of life for existing authorial patterns, kind of as Aaron was saying this morning, but also to try to build tools that really afford new models of expression. And I mean, behavior trees aren't exactly a new model of expression, but I think combining them with interactive fiction and the ways that Villanelle, I hope, helps people envision is an exciting idea. So in progress, we're working on some tool building stuff as always. One thing we want to do, of course, is be able to export games from Villanelle. One of the original motivations for wanting to do this was the idea of integrating behavior trees and planning, which I've since learned has some existing related work. So I was hoping we could include goal nodes that automatically generate behavior for characters rather than having to hand script all of it. And yeah, there's a lot more on the tool side that I'd love to talk about in the hall. On the kind of more research side, we're actively running a developer study to try to understand how intuitive people find this programming model and whether it can make character AI seem more approachable and learnable to people who may not think of themselves as someone who could be capable of writing game AI. So this developer study, by the way, it's been up on the website for months, and we've only had 4 respondents. So I implore you and your students and whoever else you can tell about it, please do check it out and participate in our developer study if this interests you at all. So with that, I'll wrap up and give you the pointer to the website where you can read more about Villanelle and information for contacting me.